guys, we are going to review some factoring. So this is stuff that you've done in Algebra 2, Algebra 1, Geometry, and it's very important. So that's why I wanted to make sure we went over it again before we jump in. So the first type of factoring we're going to look at is greatest common factor. And so, looking at example 1, I look at the two terms here, 2x and 42y, and I essentially, down here in the summary, undistribute their greatest common factor. So here, the greatest common factor is a 2. So when you factor that out, you are left with x plus 21y. And I say undistribute because if I were to distribute, I would get back where I started. 2 times x is 2x. 2 times 21y is 42y. And you always want to make sure your parentheses have no common factors. If you still had common factors in parentheses, that would mean you didn't factor out the greatest common factor. So when I look at example 2, if I were tempted to say they both have a 2 in common, I would run into the issue I just talked about, because they actually have a 4 would be their greatest common factor. So I can factor a 4 out of both, and I can factor x third out of both, or x to the third. So right here, that would leave me with just x plus, and here that would leave me with 6. So 4x to the third times x plus 6, and again, I could distribute to check. That would give me 4x to the fourth when I multiplied here, and that would give you 24x to the third. And again, making sure my parentheses had no common factors. So I would encourage you to pause the video for a moment. Just pause it and try the next two examples. And unpause and check with me. So give it a pause, try both, make sure you're on the right track. Okay, so this next one, hopefully you're just checking your answer. The 8 and the 6 have a 2 in common. A squared and A, an A in common. B and B squared, so there's a B in common. So I can factor a 2AB out of both terms, which here would leave me with 4A minus, and here that leaves me with 3B. And so 2AB was the greatest common factor of both those terms. I factored it out, and that is as far as you can factor. So the next example, you're checking your answer with me. Hopefully you already worked this on your own, and you're just checking 4xy times 5xy minus 1. So we are going to move on to trinomial factoring. So trinomial, the prefix tri meaning 3. So we have a polynomial with 3 terms. So typically that first squared, or the first term will be squared. So the first example, x squared plus 11x plus 18. Everything is positive. So the trinomial factoring is when I try to write it as a product of binomial. I'm trying to multiply two binomials to get there. And so when everything is positive, you know your signs are going to both be positive. And that's when I go back and think, what times what gives me x squared? Well, x times x. Then I think about what you can multiply to get 18, but add to get 11. So you want to multiply to get 18 and add to get 11, so that will be 9 and 2. So just like before, you can distribute to check your answer. You probably should. But when you distribute, you have a binomial times a binomial. 2 terms times 2 terms, so you'll be multiplying 4 times. So x times x is x squared. X times the positive 2 is plus 2x. Now distribute the 9 to both. 9 times x is plus 9x. 9 times 2 plus 18. When you combine terms here, x squared plus 11x plus 18, I can check and see that I did everything correctly. The second example, I would urge you to pause the video for a moment, try it on your own, and check with me. And I will work this one out. Again, like before, everything's positive. I notice it's a trinomial, so I'm going to write it as the product of two binomials. M times m is m squared. I know my signs are positive because everything's positive. And then I think about what will multiply to give 14, but combine combine like terms to give me 9. And that would be 7 and 2. The next two examples are a little more interesting because you have negatives. So for example 7, I'm still writing as a product of two binomials, but my signs will take a little bit more thinking. So I'm going to go ahead and write my y's. So the constant that I write here times the constant that I write here needs to multiply to give me a positive. So if you want it to multiply to give you a positive, it's either a positive times a positive or a negative times a negative. I know when I combine like terms from my outer and inner, I need a negative. Therefore, I know my signs are minus, minus. And I think about what I can multiply to give me positive 8. So it could be negative 8 times negative 1, negative 4 times negative 2. I start listing the factors, and I look and see that negative 4 and negative 2 will combine to give me that negative 6. So I am done factoring. Example 8, again, you're welcome to pause and then check. I'm going to write my trinomial as the product of two binomials. I know w times w is w squared. Now, when your last term is negative, your signs are going to be plus minus. The only way to get a negative is a positive times a negative. And in this case, if you wrote a minus then a plus, it would not matter, because the order of your multiplication doesn't matter. So for negative 15, it could be negative 5 times 3 or 5 times negative 3. And I want to combine to get positive 2, so I know the plus is with the 5, the minus is with the 3. So down there on a summary, I'm not actually going to summarize, I'm just going to write a warning. And that is to check for common factors first. So you want to make sure that there wasn't a greatest common factor that you could have factored out before you just jump in. So here we have trinomial factoring where the leading coefficient is not the number 1 like they were before. And so these take a little bit of work. So I actually use a trick method called slide and divide. Some teachers do not like it. I prefer it. It's up to you what you do. I'm going to go ahead and show you my slide and divide method. And then it'll be up to you what you do from here on out. And so the reason I do slide and divide, so if I were to start right away writing this as a product of binomials, well, I know I need a 3y times a y. However, when I go to write my plus and my minus, I'm not sure if I should write the plus here or the minus here. And so some people are really good at just thinking about it. Some people prefer to guess and then check. I typically just do slide and divide. It's faster for me. So I will show you what I do. Excuse the computer freaking out there. All right. So slide and divide. So step 1 is to slide. So step 1, you slide, and what that is you multiply, you multiply A times C. And by A times C, I mean that first and that last. So in this case, when I multiply the 3 times the negative 15, I get y squared plus 4y minus 45. Now the second step is going to be to factor. So now I have something much easier to factor. It's a trinomial like the ones we were just doing. Y squared plus 4y minus 45. So I can see that it's y times y. That number is negative, so I know it's a positive times a negative. And in this case, it doesn't matter where I write the plus and the minus, because they're both just a y. And so I think about what could give me the 45, the negative 45, that combined to give me a positive 4. So that's going to be positive 9 and negative 5. And then here's where slide and divide fails. So slide and divide only works because I cheated. In that first step, I multiplied by the number 3. You can't just multiply things when you feel like it. So if I cheated, essentially, by multiplying, I need to undo my cheating And to undo multiplying, the inverse of multiplying is dividing. So since that first step I multiplied by 3, my next step I will divide the constants by 3. So that's what the next step I need to write down. Step 3 says divide by A. Divide by what you multiplied by in the first step. And so I get back up here, y plus 9 over 3, well 9 over 3 is 3, so that's y plus 3. And then here, if your fraction does not reduce, does not simplify, you just move the denominator forward, move the bottom up. So you get 3y minus 5. So I'll try the next one. I'll do it a little faster without writing every step. So I'm going to take the 2 to the end and multiply. So that gives me x squared minus 7x plus 6. You take the a times the c. Now I have something I can factor. I know it's minus minus, 6 and 1. They combine like terms to give you negative 7. They multiply to give you positive 6. And if you stop right there, you will miss it. Because this does not factor out, this does not multiply out, to give you 2x squared. This gives you x squared. So you have to always undo your multiplying. So I need to divide my constants by 2 since I multiplied in that first step. And when you do that, that will reduce to x minus 3. 1/2 doesn't reduce, so I move the 2 out front and I get 2x minus 1. So the next 2 examples both have a negative leading coefficient, and my advice to you is I prefer to factor that negative out first, or just multiply everything by negative 1. But I'm going to go ahead and do this one like I did before. I'm going to take the leading coefficient to the end and multiply. So I'm going to multiply the negative 5 times the negative 1. Like I said, you also have the option of factoring out a negative 1 first. Okay, now I'm going to factor this. And then the most important step, to make sure you divide. Step 1 only worked because I made it work. So since I decided to multiply by negative 5, I need to undo that by dividing by negative 5. And this first term, this first binomial, will reduce to m minus 1. And then the next one, I need to slide that negative 5 out front since this does not reduce. Negative 5m plus 1. Now I would encourage you again to pause the video and try the next one on your own. Pause it, try it, check. So hopefully you are just replaying the video and checking your work here. So I'm going to slide that to the end and multiply. Now I'm going to factor. And now I'm going to divide by the negative 3. And that gives me negative 3k plus 2 and k plus 1. And I am finished. So we will move on to the next type of factoring, special products. So for the special products, we have difference of squares. So a squared minus b squared, if you have 2 perfect squares, a squared minus b squared, that factors a plus b times a minus b. So the first example, 9x squared is a perfect square. It's 3x squared. 16 is a perfect square. It's 4. So in this case, your a would be 3x if you're looking back over here at the formula, and your b is 4. So when you factor this, you have 3x plus 4, 3x minus 4. And you could have started with a more simple example. So if you were doing like x squared minus 81, be x plus 9, x minus 9. And the reason that works, the reason that two terms, factored like this, is because when you multiply out, your outside and inside ends up canceling out. You get negative 9x plus 9x. They cancel out, which is why we don't have a middle term here. Okay, so the next one, 25n squared minus 81. You can pause it, try it on your own, check, make sure you're on the right track. Now the last one, 8, probably does not look like a perfect square to you because it's not. So here's where you have to watch out. I mentioned it earlier. You want to factor out the greatest common factor first. You always want to check that first when you're factoring. See if there's a common factor you can pull out first. So in this case, there's a 2. So I can factor a 2 out of 8 and a 2 out of 18g squared. So that gives me 2 parentheses 4 minus 9g squared. And now this is a perfect square, a different square, excuse me. So I'm going to keep the 2, and then I'm going to factor the 4 minus 9g squared, which is going to be 2 plus 3g, 2 minus 3g. The next type of special product, a squared plus 2ab plus b squared is a plus b squared. And so the easiest way to explain that would be with an example. If I were to factor out x squared plus 6x plus 9, that is x plus 3 times x plus 3, which I would prefer to be just written as x plus 3 squared. And the next example, 4g squared plus 4gh plus h squared is going to be 2g plus h squared, because it's 2g plus h times 2g plus h. And then the last special product, a squared minus 2ab plus b squared is going to be a minus b squared, or a minus b times a minus b. So the first example, when I factor this trinomial, again, you're welcome to pause and try. That is x minus 5 times x minus 5, or just x minus 5 squared. And then the final example, 19, would be n minus 6 squared. So on the summary, rather than a summary, I want to warn you of a common mistake. Many people, when they see something like x plus 3 squared, make this mistake and try to distribute that to x squared plus 9. No. Be careful not to do that. Multiple choice is always set up to catch people doing this. X plus 3 squared is x plus 3 times x plus 3, which is x squared plus 6x plus 9. So be careful. So our last type of factoring, the factoring with 4 terms. This does not show up as often. They're not usually set up this way, but I believe it's important to show you. So notice here, it's kind of leading us to the examples. You have a 5x times x minus 2, and you have a positive 7 times x minus 2. So you have a 5x and a positive 7 that are both being multiplied by x minus 2. So I am going to put the 5x plus 7 together. It's a little cheesy, but I say 5x and 7 are going to the same place. So they're going to ride in the same car together. And I would write the x minus 2 just once. So since 5x was being multiplied by x minus 2, 7 was being multiplied by x minus 2, we're putting them together, we're done. We haven't actually factored yet, we're just doing some examples leading there. the next example, 22, I'm going to do, actually, let's go ahead and skip to 21. I don't think we need the extra examples. Let's do 21. So 21, you have a negative 9 and you have a negative 5, and they're both being multiplied by n plus 3. So I'm going to take the negative 9n and the minus 5 and put them together. It's like riding in the same car since they're both being multiplied by n plus 3. Sorry guys, I was trying to save a little time so the video is not so long. So now we're going to use that process we just did to multiply something, to factor something with 4 terms. And so these 4 terms here, so it's not a trinomial. I can't just jump right into 2 binomials. However, I can still factor this. So all 4 terms do not have a common factor, but I can group them. This method is also often called grouping. I can group them into groups that do have common factors. So the x to the third and the 2x squared have a common factor, x squared. So I'm going to factor this first group. They both have an x squared. And when I factor that out, I get times x plus 2. I'm going to bring down that plus sign in the middle. And now I'm going to look at the second group. The 8 and the 16 have an 8 in common, so I'm going to factor an 8 out of the second group. And so what happens when I factor the first group and the second group is I get something with what I had above in the previous examples in orange. So now I have x squared plus 8 together, x plus 2 together, and I just factored this with 4 terms. If you don't believe me, you can multiply it out, FOIL, if you will, and check, and you will get back where we started. So the next example, the last one, there's no common factor between all 4 terms. However, if you rearrange them, there will be. So what I'm going to do, and that's mathematically sound, I'm going to take the x to the third, then the plus 2x squared, minus 5x minus 10. So I just rearranged the terms. I didn't actually change anything. The positives kept the positive, the negatives stayed negative. However, now I can group them. These first 2 terms can be factored in the second 2. So the first 2 terms I can factor out an x squared. An important step is to remember to bring that minus down, whatever the sign is in the middle. The 5 and the 10 have a common factor of 5. So if I factor out a 5, I'm just reminding myself that really I factored out a negative 5. So if I factor out a negative 5, I'm left with x plus 2. So if you do a quick distribute, you would get negative 5x minus 10. And I have another problem set up like the ones in orange. I have x squared minus 5 times x plus 2. Okay guys, that was a quick review of factoring. I hope that helps. I hope that it was all a good reminder of factoring because we'll be doing a lot of it this year.